All right. Good morning, everyone, and welcome to Estuary's 8th birthday. My name is David Ogborn. I'm sitting here in the Networked Imagination Laboratory at McMaster University in Hamilton, on the traditional territory of the Mississauga and Haudenosaunee people, the lands protected by the Dish with One Spoon Wampum Agreement, which is something that here in the Networked Imagination Laboratory we are committed to thinking and acting through as our work goes forward. It's really wonderful to be sharing today with people here and around the world to celebrate the 8th birthday of this platform for collaborative live coding. And I'm going to get the day started off with just sharing a few words, really off on the fly, really off the cuff, about what I see as the near-term future of this platform. And then as the day unfolds, we'll have many performances and a couple of workshops as well, all showcasing recent exciting uses of the platform. So I'll start just by with I think a series of thank yous. So first of all, thank you to all of the people who have made Estuary and are making Estuary a part of their exploration of live and creative coding, whether in groups or by yourself. Thank you, and looking forward to hearing from some of you today. Thank you also to the people who have worked on making Estuary work. For example, the many research assistants that have been hired here at McMaster to add features to Estuary, supported by 2 grants from Canada's Social Sciences and Humanities Research Council, or SSHRC. Thank you to SSHRC also. And last but not least, thank you to all of the many software dependencies that all of the libraries and live coding languages that get pulled into Estuary in one way or another. It's a lot of work to build a platform, but we build on the work of many others, and are always conscious and grateful for that sharing of labor that happens. So I've been working on Estuary for more than 8 years now. We say that this is Estuary's 8th birthday because it's approximately the 8th anniversary of the first commit to Estuary's source code, although work on Estuary began a little bit before the first commit, of course. There have been those 2 SSHRC grants that have been supporting it, and the second of those is coming to an end right now as we speak. And so it's a good moment to think about a little bit about what the future of the platform might be. Over the past 8 years, an increasing preoccupation for me as the person leading this work has been to think about how the platform will be sustainable and maintainable going into the indefinite future. It's been an enormous investment of my work, of others' work, of public funds to produce this, and so I think that there's a responsibility to make sure that an unspecified and indefinite public gets a benefit from that for as long as possible into the future. That can look like different things, of course. I don't think it has to mean that Estuary exactly has to exist forever, but I don't think that we're at a point yet where it is obsolete. For me, the Estuary platform and its emphasis on bringing together many live coding languages, in other words, the idea of Estuary as a multilingual live coding platform, has always been a means to an end, and a rather specific end. For me, above all, I've been most interested in the platform as a vehicle for encouraging collective improvisation with computational means. I come from a jazz background. When I finished high school and I first went away to university, it was to be a jazz guitarist, and I was immersed in the jazz tradition for those years and some years after. And I'm increasingly returning to thinking about my work and my debts to others in terms of a debt to the jazz tradition, a tradition of collective improvisation across social difference. So that's the thing I'm most interested in having happen with Estuary. That's kind of the reason why I've been doing all this stuff all these years. And so I think it's kind of exciting now that we're at the stage with the platform where a lot of the features of it are what you might think of as mature and stable. Some of them less so. And so I'm one part of the future of Estuary is that I'm looking forward to a long period now where possibly development of the platform itself will not be an emphasis anymore, and instead everyone, myself included, can maybe focus more on enjoying the platform and on using it to improvise together, on using it in other ways as well, on using it to explore the artistic possibilities of live coding and related practices. So I think for that to happen, I'm going to kind of come back to my point about maintainability and sustainability here. I think for that to happen, there has to have been thought already baked into the platform about how it can be a maintainable and sustainable thing with minimal energy and minimal turbulence and minimal disruption from constant development. And so that's something that I've been thinking about really the entire time that I've been working on Estuary, but it's kind of coming to more of a point now. Earlier in the development of the platform, I think thought about its maintainability and its sustainability was focused a little bit more on the performance of the platform, which was more of a challenge in the earlier days. Like, how do we work with the browser environment to be able to do as much live coding as possible in the browser and not, overload the browser and the computer. And I think we've made lots of progress on that. There's probably still more that can be done, but it feels like that those kinds of things are in a relatively good place now. And so over the last year or two, I'd say I've been really thinking about this aspect of it for the last 2 years and really implementing it for the last 1 year or so. The focus has shifted really to a question of like, how can the platform become something that users, players, improvisers, computational artists can customize and extend in as deep a way as possible by themselves without any need for an interaction with me, as Estuary's maintainer, or and without the need to build Estuary themselves, or to have me or someone else rebuild it for them. Building the Estuary platform itself is quite a heavy task, even for very good computers. In the old days of Estuary development, it would sometimes take 6 or 7 hours to build Estuary if you started from scratch. I don't think it's quite that bad anymore, but you still could be looking at hours, and it doesn't always work, depending on specifics of your operating system and computer. It's a heavy process. How can we get to the point where people can do the things they need to do with Estuary, and it can support those things and support all those changes and all that customization without the need to build Estuary or talk to its maintainers. And a first, much more limited, I think, exploration of this principle was the resource system So, starting maybe 3 or 4 years ago, I don't remember exactly when, we added a system to Estuary that supported sample banks that could be located anywhere on the internet, provided that they were served by a CORS compliant server. And at this point now, in late 2023, that system is relatively mature and widely used, and I think it's been a good thing. And it forms that system, the resource system that allows people to have remotely located sample banks wherever they like. That has formed a bit of the model for the thing that I'm going to talk about next, which I think is a really exciting aspect of the near-term future of Estuary, the Exolang system. So Exolang is a pun on Esolang, or esoteric programming language. Esoteric programming languages are languages that are often made for as conceptual art experiments, or to explore something about the nature of programming languages. They are often very difficult to use, although not always, and they may even, in some cases, not lead to any computational result, or they may be even impossible languages. And so punning on that, the Exolang, or exoteric programming language, goes with the meaning of the word exoteric as meaning like external or out there in the world. And the basic idea of an Exolang is that it's a live coding language that can work with Estuary. Maybe it can work with other things or in other ways as well. But where the source code, where the running code of the language exists somewhere else, it's not directly part of the Estuary client in any way. And so the first example of such a language developed over the last couple of years was the language Locomotion, which has quietly been an Exolang in Estuary all this time. And if I go into Estuary solo mode and I identify the language I want to use this way, and then make a simple program in Locomotion, like the easiest Locomotion program ever, just the program dancer, that works. But what maybe is not so obvious at first is that this language Locomotion isn't part of the Estuary client. When Estuary accesses Locomotion, here's the Locomotion standalone on a completely separate website. Estuary is grabbing the built JavaScript for this language completely from this other website. None of the Locomotion code is there at the Estuary website, and so that makes it an Exolang. So I should just say that Locomotion, this language I'm using here briefly for this demo, is a language that was initiated by Kate Sikio and myself as part of a project funded by Canada's New Frontiers in Research Fund to make a language focused on dance and choreography. And it's been a lot of fun to work on that project, and there's a few performances later today that feature the Locomotion language in various ways. So I'm looking forward to that. So maybe this is the time to just reflect a little bit on what the advantages of these Exolangs might be a little more, and then I want to finish up by looking at how one works. So to think about the advantages of an Exolang a little bit, I mean, I think I've already alluded to what I see as the most important one, the fact that without any need for a conversation with the maintainer and without any need to rebuild Estuary, people can implement their own live coding languages that can access anything that can be done in the browser, and they can add them to Estuary, and then they are able to use them in the multilingual collaborative space of Estuary. And they don't have to necessarily implement those the collaborative features in any way. They can take advantage of all of the collaborative and multilingual features that already exist in Estuary, and they can insert their language into that context. And I think that is potentially a powerful thing. I think, and maybe just to go down a little bit of a rabbit hole here, I think that, and to think about what the advantages of multilingual live coding itself are, I think they are many, but I think the most mundane form, the most pragmatic form, if you will, of an advantage of multilingual live coding is simply the fact that in collaborative improvisational settings, it lets people choose the language that fits their purpose, or that best fits their purpose, whatever that might be. It might be a language that they're more familiar with. It might be because a language supports a particular type of result or output that is more difficult to get with other languages, or it might be that they just like what the language looks like and what it communicates to the audience through its textual surface, or some combination of these advantages. So in that sense, I think the possibility of making an Exolang and just adding it into this context with all these other languages, only adds to that. Only further supports that that goal of having a multiverse of live coding languages. But I think the advantages of Exolangs don't quite end there. I mean, another advantage of the Exolang that I've been keenly aware of while working on this language, locomotion, is that it lets you quickly test and iterate new languages in a collaborative environment like Estuary. So I'm really getting at the advantage for the developer of a language here. If you're the person making a live coding language, being able to test it and do things with it quickly in Estuary as you make it, and not having to rebuild Estuary, is super exciting. And it's been, a real pleasure to work on locomotion for multiple reasons, but one of them has been just that the speed of that development cycle, and the role of Estuary in the development cycle has been a pleasure. I think another advantage, possibly, of Exolangs is, and this is a more subtle one, relates to the question of different versions of languages. So live coding languages tend to evolve fairly quickly. I think they should. It's in the spirit of live coding languages that I don't think they should have to sort of like adhere to some standard of very high standard of backwards and forwards compatibility. It's great if the languages themselves are sort of like constantly changing and evolving and breaking as the more short-term event of live coding itself is also about improvising and changing and breaking and going in unpredictable ways. But obviously that can create problems for the collective pedagogy of live coding. And that's, the most extreme limit case of it is that in multilingual live coding, I think we want to be supporting this idea of people can work with the language that they want in the environment. And if the languages themselves have different versions, as of course they do, we need to be able to support that as well. I need to be able to say, I want this version of punctual, or I want that version of punctual. So prior to the Exolangs, that kind of fine-grained selection of the version of a language was really just completely off the table, because it was so much work just to bring these languages together in Estuary's rendering engine. The idea of bringing multiple versions of each language, just, completely off the table. But as languages become Exolangs, having a different version of any of these languages is really as simple as just pointing the reference for making another reference for an Exolang that points to a different place where an older or newer version of the language has been archived. So I think those are the main advantages of Exolangs. Maybe there's a fourth one, which might be something about how, definitely there's a fourth one. So I think the fourth one is about how the formalization of the Exolang API, the Exolang application programming interface, which I'm going to show to people in a second. I think that the mere existence of something like that will encourage or can facilitate interesting pedagogical situations wherein people make their own live coding languages, because I think it definitely lowers the bar for making your own live coding language in a significant way. So yeah, there's that too. I'm going to change here to the backup server for Estuary, and the reason I'm changing to the backup server for Estuary, intramuros.mcmaster.ca, is because it has the more bleeding edge version of Estuary where the Exolang features are working more in the way that I imagine they will eventually work. And if I go to solo mode, here I am, and if I go to the terminal and I type show resources now, I'll get something different than what I will have gotten in yesterday's version of Estuary, so to speak. So when I do show resources, the first item in the list, the one labeled 0 here, is the list of default sound samples that is provided by this Estuary server. And then the next item is labeled append Exolang, and it's got a URL, which is a reference to a JavaScript file that contains all of the code for locomotion, and then it's got the phrase locomotion. And then there's another one after that as well. So we're seeing here how Exolangs are now being managed in a way that is similar to the way that sound samples are added. And if I wanted to adding my own Exolang is as simple as, I'm going to just copy this URL so I can reuse it. Oh, my mouse is a bit finicky. Adding an Exolang either to solo mode or to an ensemble is as simple as doing the Exolang command at the terminal, providing a name for the language. I'm going to call it this one my language, and then providing, again in quotes, a URL to the JavaScript for that language. Whoops, that's not it. I don't think my paste worked. Let's try that again. Oy. I am having trouble pasting here. There we go. So I've got the Exolang command, I've got a name for the language, and I've got a URL for its source code. And when I put that in, it says Exolang reference added, and now when I do show resources, there's another one on the end. In fact, it's just locomotion again, but we've given it a different name. And so now, if I wanted to use it, it would be as simple as referencing that name in my Estuary code panel, and then providing whatever source code is going to be passed to that language. And there we go. We have locomotion, except we've called it something different. But the point is, I could have put any URL that had a valid Exolang in it there, and it would have worked on the fly, which is just super fun and exciting. So I want to take a moment now to look at how Exolangs work behind the scenes. And if we go to the Estuary source code repository at GitHub, and we go into the static folder, there's actually an example of an Exolang that is provided there. This file here, exolang.js, and we can look at it to get a sense of how Exolangs are built. So this Exolang, exolang.js, is an example of an Exolang that doesn't do anything except print stuff to the web console. And so I've made it in order to kind of show how Exolangs work and also potentially to test how they're working in Estuary. So it's JavaScript, and it's a JavaScript module, and it's an ES6 module for JavaScript. And the module exports exactly one thing, a function called Exolang, and all that function does is it returns an instance of an object that is an Exolang. And that object, the class that defines that object, is defined here in this file, and for the purposes of Estuary, nothing else needs to be exported. You might want to export these other things if you were also using this file for things that didn't have to do with Estuary, but that's not the case for this example. So this function Exolang is what Estuary is going to call the first time that it needs to do something with this Exolang, the first time someone uses this Exolang. And we can see that that function is going to return the object made by this function. And in this case, that object gets made, and the text new Exolang example constructed is going to get printed to the web console the first time that happens. So now the rest of this module is all methods that are added to this object that are meant to respond to specific moments in the live coding situation. And the first, and arguably the most definitive moment in the live coding situation, is the moment in which the live coding artist evaluates or defines some code. You know, the moment they hit the play button in Estuary, they press Shift-Enter, that evaluation moment. That's the moment in which the artist says, here's some code, this is what I want the program to be going forward. So in the Exolang API, this is handled by having a method called define, and it takes one argument which is called args, and args is a JavaScript object or dictionary, and I'm using an object or dictionary as the way for passing arguments into almost all of these functions, because that means that the actual specific items that are in the dictionary that represent important information about the situation, we don't have to keep track of the order of those specific items because they're all just entries in the dictionary. So that means that as we go forward and as things get added or much less likely subtracted from the Exolang API, the code that people have written should mostly, hopefully, continue to work, which I think is, you know, part of that long-term maintainability or sustainability I'm aiming for. So right now, as the example suggests, args contains 3 items of interest: zone, time, and text. Zone is a number that reflects which specific panel in Estuary the code was evaluated in. So people who are longtime Estuary users who have gotten good at using the view system to make their own arrangements of panels in Estuary will know that the code panels all have a number that uniquely identifies them. Well, zone is that number. Time is the time at which that evaluation took place, which is often an important aspect of figuring out what the results of an evaluation should be. And text is the program code itself. So with those 3 things, you know, an Exolang should be able to, you know, we'll probably store them, maybe parse them, maybe store the results, and then when other functions are called, different things will happen depending on what the result of this was. But because this is just an example Exolang, it just prints the 3 things at the time. So when we try this out in Estuary in a second, we evaluate some code, we should see Exolang example received define, and we should see the zone, the time, and the text for that code. And then it has to return something, it has to say whether it is successful or not, and if it's not, it has to give an error message. And this is so that the little marker in Estuary that says whether there's an error there or not can be updated, and also if there is an error, so that the information about that error can become available if you hover over the marker. And it's also possible to provide further info in the successful case, although Estuary doesn't yet have any way of displaying that info. For example, the live coding language Punctual, when you evaluate, it turns the code into some web audio API results, and it also turns it into a fragment shader that runs on your accelerated graphics hardware. When you use Punctual, it also stores the text of that fragment shader as info, and in the Punctual standalone you can get access to that and see that in order to kind of think about the program that you've written in a deeper way. So very soon that extra info that can be part of what the define method returns should be visible in Estuary. I'm going to go through the remainder of the functions in the API more quickly. So clear is a function that is called when a zone is no longer being used for a particular language. So let's say we had a zone, it was being used for locomotion, and now the user has deleted everything in the zone and evaluated that empty box again. The clear message is going to be sent to locomotion with the zone argument set to the number of that zone, so that locomotion can get the message, to stop doing anything that pertains to that zone. So the next three functions are where results are actually rendered. So every time Estuary wakes up and needs to draw or calculate musical events, that kind of thing, before it calculates events for a particular zone, before it does any drawing for a particular zone, the pre-render function is called once for every language that is currently in use. And the purpose of this is just to do anything that needs to be done only once, no matter how many zones of code you have. For example, in graphical languages, there might be things that have to do with sort of setting things up that multiple zones then go on to use. So pre-render gets called. And then the next thing that happens is that render gets called for every zone that has active code. And a bunch of arguments are provided, including can draw represents whether this is happening in an animation frame, and so whether drawing is allowed or not. And window start time and window end time are important. If for languages that generate events, like languages like title type languages that generate triggers of samples, there's always a moving window of within which events should be calculated, and it's always slightly in the future. So window start time and window end time reflects that window. And for languages, finally there's the return value. For languages that draw, and that only draw, they don't need to do anything, they can just return an empty list. But for languages that are generating things like sample events that are going to be played back by WebDirt or SuperDirt via the SuperDirt socket, or other things that are have events as their results, they can return a list of those things, and it's just a list of JavaScript objects with the appropriate keys. So after all that's happened for all of the zones, post-render is called as a kind of like pre-render. Like for every language that is in circulation, post-render is called once, regardless of how many zones there are. For example, the language Punctual uses the post-render part of the cycle to actually draw to the screen. All of the drawing that happens on the individual zones happens invisibly, and it's only during the post-render that the results are transferred to the screen. So that's a useful model. So the final function in this example is called setTempo, and it takes its arguments are a tempo in the format that is expected by the library PureScript tempi, which is right here, and so basically it's a JavaScript object that has 3 arguments: frequency, time, and count. Actually, sorry. It's this one called foreign tempo. So it's a JavaScript object that has 5 members in it: the numerator and denominator of the tempo's frequency, a time, that's a number that anchors the tempo, and a count as a numerator and denominator that are how many beats have passed at the point in time indicated by the time. So this is a great way of representing metric grids, and completely JavaScript compatible. And so the set tempo function is called at least once anytime the tempo grid changes in Estuary. And this is one of the parts of the Exolang API that is incomplete at the moment. In the the next month or so, I'll be filling this example language out with more of these things that set or communicate aspects of the environment around the Exolang to the Exolang. So the last thing I want to do before stopping here today is just to show this test Exolang in motion. So here I am on intramuros.mcmaster.ca. I'm going to use the Exolang command in the terminal. I'm going to call my Exolang test, and I'm going to access that Exolang example that is provided as part of the Estuary client. So there we have it. And now I can access the language over here. I'm going to open the web console before I do this. Here we go. We see some messages that came from Locomotion. The language was called test, and I'm just going to put some text here for my program. And when I evaluate, a bunch of stuff, all of those console.log statements from the JavaScript we're just looking at, they're all firing away. And just to make this manageable, I'm going to erase the program to stop it. And now if I back up in the web console, we can see what just happened. So when I evaluated, it loaded the Exolang. It didn't load the Exolang until that moment. Here's that Exolang constructor being called, and there's some debugging messages that come from Estuary about whether it has certain functions or not. Here's define being called for zone 4, because that's where I evaluated it. That's the time that I evaluated it, and the text was my program. And then after that, what we see again and again is we see pre-render and its arguments. We see set tempo sometimes. Then we see render, and then we see post-render. And we see that again and again and again and again and again and again and again as all these tiny little frames of live coding results are rendered. So there you go. That's a whirlwind tour of the Exolangs. I think it's a super exciting feature. I hope that the next couple of years are a time where there's lots of experimentation with Estuary, lots of playing together with collective improvisation, and increasingly, I hope, also lots of playing together with new and weird and bespoke and imaginative languages of people's own creation. Thanks for listening, folks. If there's any questions or comments, I think the best place for those is probably the Estuary Discord. Enjoy the rest of the day, and